For this pencast, we will be finding the indices of a plane. So we will be looking for a set of numbers which will define the location and orientation of the plane within the cubic unit cell. Now our first step in solving this is to choose the origin. Now the origin can be at any point within the cubic unit cell, but for convenience we will put it at the cube corner which is closest to the plane. So that will be right here at 0, 0, 0. Now the next step is to find the intercepts. In order to find the x-intercept, we'll start at the origin and travel along the x-axis until the plane intercepts it, which is right here at 1. To find the y-intercept, we'll go back to the origin and we will travel along the y-axis until the plane intercepts it, which is right here at 1/2. And to find the z-axis, we will travel along, or we will go back to the origin and travel along the z-axis, and as you can see, the plane never intercepts it, so we say that the intercept is at infinity. Now the next step is to take the reciprocals of these numbers. So we will take 1 over the x-intercept, which is 1, and that will equal 1. We will take 1 over the y-intercept, which is 1/2, and that will equal 2. And finally, we will take 1 over the z-intercept, which is infinity, and that will equal 0. Now our next step is to simplify these numbers to the smallest possible integers. As you can see, these numbers are already the smallest possible integers, so they will remain the same at 1, 2, and 0. Our next step is to replace any negative signs with bars. As these numbers don't have any negative signs in front of them, they will all remain the same. So 1, 2, and 0. Now our final step in solving this is to add the round parentheses. So our final answer will be open parentheses, 1, 2, 0, close parentheses. And there you have it. Those are the indices which define this plane. Now I wanted to point out that if the plane is shifted, the new indices will be equivalent to the old ones. So this plane, which is the same as the first plane shifted to the right, should have the same indices as before. So to solve for these indices, we will first choose the origin. Like before, we will choose the cube corner which is closest to the plane. So I will pick the new origin O' to be right here at 1, 1, 0. Now to go along with this new origin, there will be a new set of axes which I will call x', y', and z'. Now our next step is to find the intercepts. So to find the new x' intercept, we will go to the new origin, O', and we will travel along the x-axis until the plane intercepts it, which it does right here at -1. To find the new y-intercept, we will start at the new O' origin, and we will travel along the y-axis until the plane intercepts it, which is right here at -1/2. And to find the z-intercept, we will start at the new origin and travel along the new z' axis until the plane intercepts it, which as you can see it never does, so we can say the intercept is infinity. Next we will take the reciprocals of the intercepts. So we will take 1 over the x' intercept, which is -1, and that will equal -1. We will take 1 over the y' intercept, which is -1/2, and that will equal 2. And finally we will take 1 over the z' intercept, which is infinity, and that will equal 0. And our next step is to simplify these numbers to their smallest possible integers. As you can see, -1, -2, and 0 are already at their smallest possible integer values, so they will remain the same as -1, -2, and 0. Now the next step is to replace the negative signs with bars. So -1 will become bar 1, -2 will become bar 2, and 0 will remain as 0. Now our final step is to add the parentheses. So our final answer will be open parentheses, bar 1, bar 2, 0, close parentheses. Now as you may recall, multiplying the indices through by -1 will in fact keep them defining the same plane. So bar 1, bar 2, 0 are the same indices as 1, 2, 0. That means that this plane right here has the same indices as this plane right here, despite it being shifted to the right. If you have any further questions on this topic, make sure to visit our YouTube channel, Materials Concepts. And thanks for watching!